Assalamualaikum warahmatullahi wabarakatuh. My name is Yusma Laili binti Muhammad Yusuf from AS222 program, and today I would like to present my thesis entitled A Review on Adsorptive Removal of Eriochrome EBT dye by Activated Carbon. Basically, the outline for this presentation consists of Chapter 1 Introduction, Chapter 2 Literature Review, and Chapter 3 Conclusion and Recommendation. For background of the study, dye present may cause environmental damage to aquatic species due to the high organic content. Various treatments such as electrochemical treatment, coagulation, absorption, and precipitation can be used to remove dye. Adsorption is the most common and effective technique in the physiochemical method. In the water treatment industry, activated carbon have long been known as the most common and highly used adsorbent. However, this wide use is constrained because it is costly and difficult to regenerate. The study on the manufacture of activated carbon from raw material is gaining interest due to its low cost and highly suitable characteristics. For the problem statement, EBT dye is a dye that is used in the textile industry as well as in labs to determine the hardness of water. As we know, water is very important to all forms of life in the world, so discharge dye into water bodies without proper treatment pose a big risk. Biological treatment is not very productive in the treatment of dye waste. The physical approach of adsorptive process by activated carbon is believed to be effective for dye removal. There are three research questions for this study. The first one, how is the absorption technique used to remove EBT dye? Why is activated carbon normally used as adsorbent for removal of EBT? And the last one is, how are the performance of different sources of activated carbon used for the removal of EBT? The objective of this study are to highlight the absorption technique for removing EBT dye by activated carbon, to explain the use of activated carbon as adsorbent, and to compare the adsorptive removal of EBT with different sources of activated carbon. First, in this chapter 2 is the toxicity effect of dye. But what is dye? Dye are organic-based synthetic coloring substance that contaminate both the ground and the groundwater. So, the discharge of dyes into wastewater from the industry causes serious environmental risks and harms aquatic and terrestrial life. Some of them are carcinogenic and mutagenic. Therefore, prolonged exposure to high amounts of them will cause significant harm to the reproductive, nervous, and immune systems. Dye in aquatic environment cause water coloring, which lowers oxygenation of water surface, harming aquatic plants and animals. Eriochrome black tea EBT dye is one type of dye that I'm focusing on in this study. EBT was an azo dye that accounted for over half of the global dye supply. In acidic organic solvent, EBT has a high solubility, whereas in water, it has lower solubility. The chemical composition of the EBT dye is shown in this figure. It is also widely used for EBT in complexometric titration and biological staining as an indicator. That's because of its simplicity, in which it is simpler to perform and can be implemented on a broad scale. The adsorption technique is used to remove EBT dye. Absorption is one of the simplest, most reliable, and equivalent low-cost methods used to extract pigments, heavy metals, and other inorganic and organic wastewater pollutants. So the absorption on mechanism occurs from the interaction between the surface of the adsorbent and the adsorbate. So this technique is capable of removing molecules or ions from the aqueous solution and in the removal process for many solutes. There are some sources that can generate activated carbon. This activated carbon can be obtained from low-cost material with a high carbon concentration, also low in organic content. It has been reported that a number of raw material may be used to produce activated carbon. Many recent studies also have shown that different agricultural solid waste may effectively remove inorganic or organic contaminants, including dyes, when used as adsorbent. So not only the agricultural, but also the non-agricultural product can be used as the source of generating activated carbon, like waste automobile tires. Also, several research have been published on the use of agricultural waste biomass residues in activated carbon generation. So, these certain industrial and agricultural waste product, natural materials, and biosorbents constitute potentially cost-effective alternative sorbents, as it requires low cost because only require minimal process. Also, is available in nature or waste material from some other industry that has lost its economic value or is a byproduct of additional processing values. Wood bark is one of the agricultural solid waste that can absorb dyes due to the unique bark chemical composition of biomass. Wood bulk is often disposed of by burning, resulting in air pollutants that are detrimental to the environment and human health. By transforming wood bulk to activated carbon, which can be used to remove Eriochrome black tea (EBT) dye from the solution, wood bulk can be beneficially used. Waste seeds are another agricultural solid waste that can be used to absorb dyes. The way this waste is disposed is not safe for the atmosphere, since it is being used as burning fuel in the home or disposed of at random. It is proposed to transform rubber seed coat to activated carbon to create a value-added product that is efficient because several pores were easily visible on the surface. Fruit peel is one of the agricultural waste products that has the benefit of offering an effective low-cost replacement for activated carbon. For example, banana tree-derived agricultural waste have attracted the attention of researchers due to their application on potential in the treatment of polluted wastewater by heavy metals, dyes, and other organic pollutants. A study by Van Tuan et al. Investigated heavy metal ions absorption on banana peel-derived activated carbon. So the results show a significant potential with well-defined absorption capabilities for environment treatment, as the SEM analysis revealed a highly porous, rich defect structure. There are several parameters where absorption process will be affected. The pH solution is one of the most significant factors influencing the adsorbent capacity. Different pH contributes to different degrees of ionization of the adsorptive molecules and the surface properties of the adsorbent. To determine the pH effect on dye removal, its absorption was tested at different pH range. De Luna et al. Claimed that the higher the pH, the percent removal of EBT decrease. These are consistent with Wen et al. Findings that show that the highest EBT elimination and the highest absorption capacity were achieved at pH 2. As the pH raised to 4, the ability for EBT elimination on absorption reduced to a minimum level. This is because the degree of protonation of the activated carbon surface will be smaller and therefore result in a reduction in diffusion and absorption due to the electrostatic repulsion. The initial concentration of dye is one of the conditions for absorption. As the initial dye concentration is raised, the percent elimination of EBT drops, according to De Luna et al. And Partil. Study also claimed that the rise in dye concentration allow the percentage of dye removal to decrease. This experimental outcome explicitly explained that the availability of dye molecule should be in the optimal range for interaction with the adsorbent. Effect of contact time. Equilibrium contact time is very crucial for the determination of adsorbent absorption on capacity. Absorption can be completed with a longer contact time. This ability of absorption reduces with the rise in contact time before the equilibrium is reached. The equilibrium will be reached because it has been discovered that the rate of absorption is low. This is mostly due to the saturation of the active site, which prevents further absorption. Adsorbent dosage is also one of the factors which will affect the removal efficiency. It analyzes the volume of adsorbent used to capture dye particles. A previous study by De Luna et al., where they studied adsorptive removal of EBT by waste rice hull activated carbon, found that the low dose of rice hull activated carbon causing the percent removal also low. Meanwhile, the prior study by Ribendra et al. Has been said that increasing the dosage also increased absorption to the optimal level of adsorbent up to the maximum point. Meng et al. Also claimed that the percent elimination of EBT steadily improved when the adsorbent dosage is increased. Lastly, effect of temperature. The temperature analysis shows whether the mechanism is exothermic or endothermic. A prior study by Wen et al., where the study is about the removal of EBT by sludge-derived activated carbon, show that the absorption capacity increased with the temperature. So, according to Katerisen et al., stated that when the temperature is excessively low or excessively high, absorption is weak. In conclusion, this review summarized the toxicity effect of dyes, their removal method, which is absorption by using the activated carbon, absorption parameters, isotomes, and kinetics. Altogether, activated carbon is chosen to be the absorbent as its characteristic is effective among the variety of absorbents. Absorption methods are recently gaining more interest than the other methods as a result of their significant advantage. The simplicity and low-cost method of absorption make it more preferable compared to other methods. Dye removal is strongly relies on the system parameters include pH, initial dye concentration, contact time, adsorbent dosage, and temperature. Lastly, the recommendation, adsorbents such as activated carbon should be prepared with minimal human ecological impacts for long-term environmental applications. The possibility of disposing only the dye after the adsorbent have been used can be thoroughly investigated. Therefore, more research should be conducted to investigate the possibility of using utilized adsorbent in dye pollution studies. That's all for my thesis presentation. Thank you.